Now let us solve the problem together. But before starting solving the problem, I prefer to describe the definition of the notion of uniform continuity of a function here for you first. So let us say that I have a function f which is from r to r, meaning that this function takes a real value from me and gives a real number back. We say that this function is uniformly continuous on the set R if the following statement is true. The statement is this. For all epsilon greater than 0, this symbol means for all, there exists a delta greater than 0, this symbol means there exists, such that for every pair of real numbers x and y, for all x and y belonging to the set R, if the distance between this pair, meaning the absolute value of x minus y, is less than this number delta, then the distance between the corresponding f values, meaning the absolute value of f of x minus f of y, is less than epsilon. If this statement is true, we say that this function is uniformly continuous on R, and if this statement is false, we say that this function is not uniformly continuous on R. But because this is a fairly complicated statement, it contains three quantifiers. For all, there exists, for all again. These are called quantifiers in mathematical logic. So let us try to have a better understanding of this fairly complicated statement. I think the language of this, the metaphor of playing a game might be useful here. So let us consider that we have three players in this game. Two people will work against me. So the people, let me call them person A, I myself, and person B. Okay? So if the function that is given is, let us assume that if the function given to me is uniformly continuous and I can show it, I will win the game. But if this function is not uniformly continuous, I will lose. And let us assume that A and B are super intelligent people, meaning that if there is a mathematical way for them to win, they will definitely win. They don't just lose the game to me by accident or by bad play. There is no way for them, let us assume that there is no way for them to actually play bad. If they lose, they have to, they have to lose. There is no way for them to win. If there is a way for them to win, they win. Okay? So let us try to see that. These two people are actually against me. The duty of the first person is to offer a positive epsilon to me. And then that person has no longer control on the epsilon that he passes to me. So then I take that epsilon and I think about the epsilon given to me. My goal is to prove the existence of a positive delta. So one way of doing that is just offering the delta to person B. So I pass by looking at the epsilon this person gives to me, I think a little bit and I offer my delta and I pass my delta to B. And then I lose control over my delta. But I have to design my delta in a way that no matter which pair of real numbers person B chooses, every pair, if that pair respects this inequality, meaning the distance between that pair is less than the delta that I offer to person B, then this inequality for the epsilon offered by the first person is also guaranteed. So if I can prove the existence of such a delta, then I will win the game, meaning that the function is uniformly continuous. If not, I will lose the game. What is the meaning of if not? If not means there is an epsilon that this person can offer for which no matter how smart I am or how hard I work, I will not be able to offer a positive delta that works. So it means that whatever I offer for delta, no matter what it is, the person B can engineer a pair of real numbers x and y in a way that that pair respects this inequality for the delta that I offer to him, but violates this inequality for the epsilon offered by person A. So if this happens, I will lose the game, and this means that the function is not uniformly continuous. Now, in this problem, a very simple function is given to us, and that is f of x is equal to x squared. So let us see that I evaluate, is it worthy from my side to play this game with this function or not? Okay? And then my evaluation shows, according to the problem, we are supposed to show that this is not uniformly continuous. So I need to understand why I will lose this game if I start betting on this function for uniform continuity. Yes? Okay. In order to evaluate that, let us start from here. I want to get the feeling, is it a good idea to actually play this game for this function or not? Because my goal is to fine-tune this delta in a way that this inequality is satisfied for a given epsilon. Okay, so let me evaluate this one. So let me put it in a star. I don't want, this is not part of the solution to the problem. I just want to evaluate or assess the situation, okay? So f of x minus f of y, f of x is x squared, f of y is y squared. Why is that? Because this function is just a squaring function. No matter what I put in, the function squares it and gives it back to me. So when I put x, it gives me x squared. When I put in y, it gives me y squared. But this function, this expression can be factorized to x minus y, x plus y. And then we know that the absolute value of a product is the absolute value of the first one multiplied by the absolute value of the second one. So my goal is to make it less than epsilon. Okay? So this is part of my assessment. And then I realized that this is not indeed possible. Might be I can offer a delta that they accidentally lose the game to me, but I told you that they are super intelligent and this is not going to happen. The only thing that I have in my hand to control the situation is fine-tuning this delta. Okay? And my goal is to make this one less than epsilon. So I will try to make this expression as small as possible. The smaller, the better. It will increase my chances to make this smaller than epsilon. Yes? Okay, I tell to myself, I have delta under my control, and I can choose my delta very small. By choosing delta very small, this person has to respect the laws of the game. So the pair that he chooses should also be less than my delta. So when I choose my delta is small, automatically this distance is also small. So the factor here is under my control. I can make it simple. I can force it to be small. But I do not have any control over that part. Because that person can choose x and y wisely in a way that it does not violate this condition, but it violates the condition that you see here. For example, let me give you a concrete example. Let us say that x is 1,000,001 and y is just 1,000,000. Okay, this quantity, the difference between them becomes just simply 1, which is of course a fairly small number. But on contrary, if I calculate that, it becomes 2,000,001. 2,000,001 is a huge number, so that I multiply it by 1, it becomes actually a huge number. So this means that no matter how I choose delta, even if I force delta to be extremely small, then of course, this part becomes extremely small, but because this person has freedom in his choice to choose x and y, he can choose them in a way that even though this part is small, but this one is extremely large so that the product becomes fairly large and exceeds the pre-assigned epsilon, then I will lose the game. Okay, so that's the idea. That's more or less the idea behind this problem. But I want to polish this argument that I just mentioned and promote it to a rigorous mathematical proof. Okay? So I realized that there is no chance for me to win the game. So let me write it precise. So I was thinking that, okay, what happens if that person offers me a particular value for epsilon, say epsilon equals to 1? For the time being, don't resist about why I choose epsilon equals to 1. Everything becomes clear if you see at the end of the problem. So epsilon is equal to 1 is offered by that person. Then I say to myself, is it possible for me to offer a positive delta that whatever the person B chooses for x and y, this guarantees that one for epsilon equals to 1. Then immediately I realize no. For example, let us assume in contrary that this person offers epsilon equals to 1, then I find a delta positive. Okay? For the time being, I don't know anything about delta, but I'm just assuming that because if I'm going to win the game, I have to offer a delta for every epsilon. So even if the epsilon is 1, I should be able to offer a delta, and delta is positive. Then I have to pass my delta to person B. But because this person is super intelligent, he immediately engineered a little bit of weird form of x and y in this way. He takes my delta and say that, okay, I introduce x to be 1 over delta plus delta over 2. I cannot resist about that, yes, because I myself put delta to him, I pass delta to him, and delta is positive, so 1 over delta is defined, delta over 2 is also defined. So delta is not 0. And then he also writes y equals to 1 over delta. And he said that, and then I realized that, oh, I lost the game right away. Why? Because the pair of numbers he actually presented respects this condition and violates this condition for epsilon equals to 1. Let us check. Absolute value of x minus y for this particular engineered pair is 1 over delta plus delta over 2 minus 1 over delta, and then this one and that one are gone. The absolute value of a positive number is just the positive number itself, and you see that delta over 2, whatever delta is, this is definitely less than delta. So yes, the pair he engineered, person B engineered, really respects the first inequality. But I want to show that this pair, even though respects the first one, violates the second one for epsilon equals to 1. For that one, I have to calculate f of x minus f of y, which I have already done here. This is absolute value of x minus y, absolute value of x plus y, but for this particular choice of person B. X minus y, it is easy. X minus y, this one and that one are gone, so it's delta over 2. And because x and y are positive, I don't need absolute values. I add them, 1 over delta becomes 2 over delta, and then plus delta over 2. And if I multiply this in, this multiplied by that becomes 1. This and that are cancelled, and this multiplied by that, it becomes delta squared over 4. But delta is positive, so this is definitely greater than 1. So I lost the game, because it was possible for person A to offer a positive epsilon to me, for which I am not able to propose any delta to person B, so that whenever this is respected, this is also respected for that epsilon. Why? Because that person takes my delta, engineer a little bit weird form of x and y. I told you that he is super intelligent. And then engineer a pair for me that even though it respects the first one, but it violates the second one for epsilon equals to 1, and that's the end of the problem. Okay? So that is why this function is not uniformly continuous. The only thing that I want to explain here is that if you are not experienced enough, might be you say that, okay, how can I construct such a weird combination of numbers, x and y, out of the blue? So here the problem is finished. So if you just write this polished form of this argument, that is done. But I want to describe, if you cannot guess these numbers, there is also some way to think about it that guides you towards doing engineering a pair yourself. Okay, so let us try to see what happens. Assume that I want to take this problem myself. So I would say that, okay, that person offers a positive epsilon, let us say 1 again. I come back and discuss about 1. And then my goal is to find delta positive, so that if absolute value of x minus y is less than the delta, then 100% the next inequality is also guaranteed. But the next equality is nothing except x minus y times x plus y less than epsilon is 1 is this one. So I ask myself, is it possible for person B to engineer x and y such that it respects this but violates this? Yes, because that's my concern. If that person B can find a pair that satisfies this one but violates that one, then I am in trouble. So I just want to think from his perspective, yes? Is it possible for that person to engineer x and y so that this is happening, but this is being violated? Being violated means that this is not less than 1, so this means that this is greater than or equal to 1. So this is my concern. Is it possible for that person to find such a pair? And by the way, one single pair is enough. So don't try to solve this problem in its full generality. Don't try to find all possible x and y's that satisfy this condition and that condition. Try to make life easier for yourself by thinking about the special cases. Okay, so one thing comes to mind is that, okay, let us take absolute value of x minus y equals to delta over 2. I don't know, whatever number that is less than delta. Okay, but be careful. You cannot choose, for example, delta minus 1. Because I told you that when that person offers an epsilon to you, you don't know yet what is your delta. How big or how small the delta is. Are you just thinking about a hypothetical positive delta? So, there is no guarantee that the delta for that particular epsilon is greater than 1 or less than 1. So there is a chance that delta minus 1 is negative, and there is no way for you to make this one equal to delta minus 1 if delta minus 1 is negative, because absolute value is positive. Okay, so this, except for that one, you have a lot of freedoms. For example, I can write delta over 2, I don't know, I can write delta over 4, or whatever it's guaranteed to be positive and less than delta. Okay, for this one, if I choose x minus y to be delta over 2, so this one is chosen to be delta over 2, I want to choose this in a way that when multiplied by that, it becomes larger than 1. So one possibility is to take x plus y greater than or equal to 2 over delta. Okay, so I'm just thinking instead of person B, is it possible for that person to find that pair? Okay, even I can make this system simpler, because it is very clear that the person cannot offer equal x and y. Because if x and y are equal, the left-hand side is 0, the right-hand side is positive, this is not working. So either x should be greater than y, or y should be greater than x. So let me just choose x greater than y, okay? If it doesn't work, then I have to be careful. I have to go back and see if the other scenario is possible. But you can see the symmetry between x and y here, so it doesn't probably matter. So I choose x in my head larger than y, so I don't need the absolute value sign. So this becomes delta over 2. And of course, there are infinitely many choices here. Any number greater than or equal to 2 over delta works, but the simplest case, why not? Delta over 2 itself. Okay, so let me take this one delta over 2. So it's positive, I don't need absolute value signs. And then you immediately realize that I engineered the pair. How? Because I can solve this system in terms of x and y, I can find it in terms of delta. So for example, if I add them, it becomes 2x, and I add them here, it becomes 2 over delta plus delta over 2, and then I divide by 2. So x becomes 1 over delta plus delta over 4. And then, for example, if you subtract them and divide by 2, you immediately find that y is 1 over delta minus delta over 4. So yes, I realize that I will not bet on this game, because if that person offers epsilon equals to 1, at least this one, and because he is super intelligent, definitely will find that. If he offers epsilon to me, there is no way for me to offer a delta so that this guarantees this for any pair that person B chooses. Because, for example, if I pass my delta to person B, that person can think according to these lines and come up with a pair that it satisfies this condition, respects this inequality, but it violates this inequality because the numbers that I just engineered gives me exactly the opposite that I want. So this is possible. And you see that this is the way. If you do not have experience, by the way, this is very common in mathematics. When you see the final solution in its polished form, there are a lot of scratch work being done in other papers that you don't have access to, and that's quite completely common in mathematics, and by the way, logical from my perspective, that you do a lot of scratch work, and when you see what is going on, you polish it and more or less write it upside down, from the bottom to the first. Okay, so this is why when you read math texts, you will see that people are offering things that you say, why? If you want to be a good mathematician, you have to be patient, follow what the author is writing for you and see what happens at the very end. Everything actually comes together. And I think it's a very, very good way of writing because there is no matter of confusion when you're reading the text. Okay. So what I'm saying is that, okay, what I did, I engineered the pair of x and y, which is of course different from the pair engineered by the examiner of the problem. Yes, if you see the solution to the problem, this is exactly the problem, the pair offered by the examiner. What I want to try to see that if you can see this, that is the end of the problem. You can just finish it here. But if you cannot find these numbers just out of the blue, there is a still way to think about it and being able to engineer a pair. And by the way, that's not the only pair. For example, here, I could choose delta over 4. And then I can write it as 4 over delta. When I solve my system, I will come up with another pair. So another pair is also working. Now let me finally talk about epsilon equals to 1. Epsilon equals to 1, for example, in this kind of argument, epsilon can be chosen to be 2. Yes, that person can also choose epsilon to be 2 or not. In this case, no. Why is that? Because if epsilon is equal to 2, this pair does not work at least. We have to engineer another pair. Why? Because even though that pair still respects this less than delta, but this one, when I do the calculation, I will end up here. But this one, less than epsilon, epsilon is 2, is not a contradiction on its own. Yes, when you write this is less than 2, this is possible. I'm not saying this is 100% correct, but this is not contradiction by itself. But this was 1 plus delta over 2 divided by 4 less than 1 was a contradiction. So this cannot happen. But this might happen or might not happen. So if you choose epsilon equals to 2, then you cannot follow the same pair. Yes? You have to change your pair. You have to re-engineer the pair. Okay, but if I have chosen epsilon to be 0.5, the same pair will work. Because then at the end, instead of having this less than 1, I will have it less than 0.5, even better. It's a more contradiction, yes, now. The other part of this video, I think it's a good idea to also understand this problem from a geometrical point of view by drawing the graph of the function. Okay, so this function that you see here is the function f of x equals to x squared. So I have rescaled the x and y axes in a slightly different way so it becomes more transparent what I'm going to describe on it. So let us understand why this is not uniformly continuous. Okay, person A offers epsilon equals to 1. Okay, so for example, and then I am trying to look for a positive delta so that for every pair x and y in R that person B chooses, if absolute value of x minus y is less than delta, then absolute value of the corresponding f values is less than 1. And I want to show that if person B is intelligent, I will not be able to win this game. Okay, so let us, for example, try to analyze the problem. So person A offers epsilon equals to 1. Because epsilon equals to 1 is in this inequality and this inequality I have f of x and f of y, I will locate epsilon equals to 1 on the y-axis. So let us, for example, put epsilon equals to 1 here. So let me choose this interval. This length is 1, and I say that this is my epsilon. And my goal is to find a positive delta. So I tell to myself that let me find delta at least working for the epsilon located here. So one way to do that, I reverse engineer. So I go backward like this, and then I get that one. I come back here. So that is 1 point. I go backward from here. I intersect this one. I go vertically, and I get this one. And then I offer this delta. Okay. So I want to say that, okay, let me offer this positive distance to be my delta. Okay? And then if I pass this delta to person B, no matter what points person B chooses in this interval, so this person chooses X and chooses Y, if, of course, he chooses X and Y within this interval, then it is guaranteed that this is respected. This is also automatically fulfilled for this very particular pair. Why? because if I want to see what is the distance between f of x and f of y, I just do like this. I go here, then this point that you see here is f of x, and then I use the y here. It is clear that I go within the same interval, so this is f of y. And if you see the distance between this point and this point here, this point and that point is definitely less than epsilon. There is no surprise. But the whole point is that this is just a length. There is no reason that we put this length here. So the person says to me, okay, let me take your delta, okay, because that person is also super intelligent. There is no reason that we put delta here. I take the delta that you offer, but I, for example, put it here. For example, here. Okay, so that we can, let me see if I can, yes. So I will take that delta, but I will put it here. Okay, so let me try to make it more or less the same delta. So, and then he will tell me that I will choose this pair that I am not describing. So he will chooses this pair. Let me change my color here. So let us assume that this pair is x and y. Hopefully this will work. So he will offer this x and he will offer that y, and then let us see what happens if I do the same thing. So I go up, yes, and then I go like this, and then I will do that one, and then I go like that. And then you see that I am in trouble. Do you see that? Because now, when I pass this delta to this person, that person says that, okay, I put that delta not here, but I will take and put delta here, so then I am allowed to choose this as x and this as y. And then when I reverse engineer that, I will go actually and see this length, okay? But now this length, you see, is not less than 1. This length is larger than 1, okay? So this is also a very good way of understanding. So you see that when I offer my delta, I lose control over my delta. That person can take my delta and push it to the right, so that when he chooses these points close to the ends, then the corresponding f values have the distance greater than 1. Okay, so that's exactly the idea of this problem from geometrical perspective. Below this video, you see the link to a video that I made for a function which is uniformly continuous. I think that's a good idea. If you want to understand about these problems a little bit deeper, go through that video as well. Okay, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.